Communication Group 2's focus was the feedback of the different allocations, specifically the feedback on quantity of the allocation of an item. And in general, feedback tends to be very sparse because people don't like to fill out surveys and take the time needed to do that. But we were using feedback in the agent to improve the estimated demand prediction. So our goal was to predict users' feedback about the quantity of an item that they were allocated. And to do that, we decided to look into collaborative filtering. Collaborative filtering is a technique that is used by different recommender systems in order to predict the preference that someone will have about that. And the collaborative filtering aspect of it is that you're collecting the preferences of a bunch of different users, and then based on a singular user, if they're similar to another, you're going to be able to suggest something for that user that you're similar to. And we specifically wanted to use SVD++, which incorporates the implicit feedback during the final predictions of user ratings. The equation used for SVD++, which was our method of choice, is seen here, and there are two parts. First, the baseline prediction, which incorporates the overall average rating for that item, and then the user's bias and the item's bias. The second aspect is the dot product seen there in the blue, and that is the interaction between a user and item. For us, we use SVD++ to estimate ratings of a user on a specific quantity of an item. The architectural design of our feedback predictions start with the inputs. First, we have the allocation quantity, and that is coming from the decision component. And then we also have our survey data, which we generated with the demand and the allocation, and that is getting direct feedback from users. Then we also have our user similarity matrix and our item similarity matrix, both coming from that initial information component from Communication Group 1. Once we have the inputs, we are going to create this aggregate ratings matrix. The first part of that is mapping the user rating of the quantity to the allocation quantity. Then we're going to add those explicit user ratings that we received from the survey at that time to the aggregate matrix called BP. And it's going to be an allocation for the user, and that allocation is a tuple of the item and the quantity. We're then going to make a temporary copy of the aggregate matrix, where then whenever there's a user with no historical ratings or they didn't rate anything, we're going to find a similar user to them in the user similarity matrix, and same with the item if there is no ratings of that item. In our now filled in temporary matrix, we are going to use the SVD++ to calculate those missing ratings. From there, we are going to again map back to our allocation history for that time t, and we're going to give the decision component a explicit and then the implicit rating, so that filled in matrix in their user item format associated with that allocation at time t. Going into more detail, we start with our inputs, that the allocation at time t is going to be a user item matrix, and the values will be the quantity allocated to the user. Then we have our explicit survey ratings, and that is going to be values of scale 1 to 5, 1 being not enough, and 5 being too much, 3 being the perfect amount allocated to the user for that item. Then we also have our user similarity matrix and our item similarity matrix, which both have values of a normalized score comparing the two users or two. Next, we have the recommender system part of our design, and that starts with our aggregate feedback data, which is in the matrix BP, and that is our previously recorded ratings. We then make a copy of that matrix, and that is a temporary copy, and we are going to populate missing users and items using the similarity matrix in order to add in the different similarities that we have calculated before. Then we populate the missing ratings for the rest of the user item at that allocation using a collaborative filtering technique, SVD++, as mentioned earlier. Once SVD++ is completed, we have filled in all the missing ratings. We then map back to that specific allocation at time, and we give the learning group for learning supply and demand a ratings filled in matrix of the user item rating of the quantity at time t. When implementing this methodology, our task was to provide ratings for the quantity of 19 different food items that were being allocated, and that was at 7 different time steps. We collected the data after an allocation occurred using a survey generated from the explicit demand that we got from the users and also the allocation of the different items at that time step. The workflow is that we first generate that feedback survey, and then we distribute the survey to the users or the demanders through Google Sheets. And then we receive the feedback from the users, generate predictions of the missing user feedback through that SVD plus methodology that we were mentioning. And then we distribute the predicted data CSV file to the learning component. The packages that we used were Surprise, which includes the SVD++ machine learning methodology, and then we had Pandas, NumPy, and a Google API used in the generation of the survey. In order to evaluate our implementation, we had the users go back and fill in what they actually would have rated if they had left a rating blank. And then we were able to look at the root mean squared error of those actual versus our predicted ratings using our SVD++ methodology of collaborative filtering. And as you can see, our root mean squared error is overall not great, and we feel like this is due to the fact that when those users were filling out their actual ratings, a lot of times they were not in the correct rating response, so they had values like 7 when the max was 5 or 0 when the min was 1. Another issue that we feel like might have impacted our poor root mean squared error scores was that our sample size was not very large, and overall we don't have as many users to be able to perform effective collaborative filtering with. So more users, better collaborative filtering. To summarize, Communication Groups 2, part of the For All AI agent, we really were focused on feedback, which by nature is sparse because users do not like to fill out feedback, and especially not all of it. We were specifically looking at quantity feedback of an allocation, and we used collaborative filtering to fill in those missing values. We found that SVD++ allowed for implicit feedback to be incorporated, giving us a better overall recommendation. When evaluating our implementation of this SVD++ collaborative filtering for feedback, we found that we had pretty poor evaluation results, but we feel like a higher sample size and being more explicit about what the ratings are possible and what the wording means for those specific ratings would increase our evaluation.